The Antikythera Mechanism, the mystery of the lost machine. Deep beneath the surface of the Mediterranean Sea, where the water turns dark and sunlight is only faintly perceived, a secret lay hidden for many centuries, one that would leave not only archaeologists but also historians, astronomers, and engineers speechless. It was not a treasure of gold, a legendary sword, or the crown of a forgotten king. It was something much stranger, something that appeared unremarkable at first glance, crusted, broken, corroded, and yet it was one of the most astonishing artifacts ever recovered from antiquity, the Antikythera Mechanism. Its story officially begins in the year 1900. At that time, Greek sponge divers discovered an ancient shipwreck on the seabed near the small island of Antikythera. Among marble statues, ceramics, jewelry, and other precious finds, there was also a strange lump made of bronze and wood scraps. At that time, no one suspected what had actually been recovered. It looked like a shapeless piece of junk, nothing that one would have immediately placed in a display case, yet sometimes the greatest sensation lies not in what shines, but in what reveals itself only upon the second, third, or 10th glance. When scientists examined the find more closely, they noticed gears, finely crafted interlocking gears made of bronze. That alone was remarkable, but with each new analysis it became clearer. This was not a simple mechanical device. This was a complex calculating machine, a device that could calculate celestial movements, an instrument that seemed to be more than a millennium ahead of its time. The Antikythera mechanism is often referred to as the world's first analog computer, and that is no exaggeration. The device was capable of representing astronomical cycles, predicting the movements of the sun and moon, and presumably even indicating eclipses. That sounds like something one would expect in a Renaissance workshop or in an 18th century laboratory. Yet this device dates back to antiquity, most likely from the 2nd or early 1st century BC. And this is exactly where the real puzzle begins. For what we long believed to know about the technological development of antiquity was shaken by this discovery. Of course, historians already knew that the Greeks were excellent mathematicians, philosophers, and observers of the sky. Names like Archimedes, Hipparchus, or Apollonius never stood for primitive conditions. But a machine with dozens of precisely crafted gears? A device that could mechanically implement astronomical predictions? That was a different league. That was not a solar calendar made of stone. That was high technology. One must soberly consider this. At some point in the Hellenistic world, that is, in the era after Alexander the Great, when Greek thought, science, and culture radiated far beyond the Mediterranean, a craftsman or a team of specialists sat at a workbench. They planned, calculated, cast bronze, cut teeth into gears, developed translations and axles. They built a device that not only symbolically represented the movements of the heavens, but mathematically and mechanically modeled them. This is not a romantic fantasy. It is the sober consequence of what this mechanism actually demonstrates. The device itself was likely housed in a wooden box about the size of a larger box. On its front and back, there were scales, displays, and labels. By turning a crank, the user could set the internal gears in motion. This allowed various astronomical information to be displayed. The position of the sun in the zodiac, the movement of the moon, probably also the known planets, although this is still under discussion. On the back, there were spiral scales that represented longer cycles. Particularly significant was the so-called Metonic cycle, a period of 19 years after which lunar phases and the solar year largely realign. Equally important was the Saros cycle, which allows for the prediction of solar and lunar eclipses. In other words, the Antikythera mechanism was not just a calendar. It was a portable astronomical model, a tool that connected time, cosmos, and calculation. But who built it, and for what exact purpose? To this day, there is no definitive answer to that. Some researchers suspect that the device may have been manufactured in Rhodes, a significant center of ancient science and technology. Others associate it with traditions that date back to Archimedes. What is certain is that it originates from a cultural environment where mathematics, astronomy, and mechanics were more closely linked than previously thought. Perhaps the mechanism was used for educational purposes. Perhaps it was a prestige object for a wealthy patron, a technical marvel that demonstrated knowledge and power. It may also have served sailors, scholars, or priests to better understand calendars and celestial events. It was probably a bit of all of that. In antiquity, science, philosophy, religion, and practical application were often not strictly separated fields. Those who understood the heavens understood more than just stars. They understood order, rhythm, time, and perhaps also the place of man in the universe. This is precisely what makes the Antikythera mechanism so fascinating. It is not just a technical object. It is a window into a way of thinking, into a world where the cosmos was viewed as an ordered whole, as a system that can be understood, calculated, and traced. The gears of this machine were more than metal. They were an expression of a belief that the world is not merely chaos, but has structure, and that the human mind can grasp this structure. This is essentially a very old thought, but it still feels modern today. When researchers in the 20th and 21st centuries began to study the mechanism with increasingly better methods, using X-rays, 3D scans, and digital reconstruction, it gradually became clear how sophisticated this device must have been. Inscriptions were deciphered, gears were identified. One recognized mathematical relationships and astronomical references. Every detail made the matter even more incredible. For the more one understood, the clearer it became. This was not a primitive attempt, but the result of sophisticated planning. Particularly astonishing is the precision with which certain movements of the moon were represented. The moon does not move uniformly in the sky. Its speed varies slightly. The Antikythera mechanism could apparently replicate this irregularity, mechanically, mind you. This is an engineering achievement that deserves respect, not out of politeness, but because it is objectively impressive. And then one inevitably faces an uncomfortable question. If people back then could build something like this, what else has been lost? For the Antikythera mechanism does not appear to be the first random attempt of a tinkerer. It seems like the product of a development that was already far advanced. Complex technology rarely arises from nothing. Usually there are precursors, designs, simpler models, improvements, competing workshops, traditions of knowledge. So if this mechanism existed, there is much to suggest that it was not completely unique. Perhaps it was one of several devices. Perhaps there were entire series of similar instruments. Perhaps there were more machines in workshops around the Mediterranean, of which nothing remains today. This is the real blow to the gut of history. Not only have we found a marvel, but we have apparently found it from a world of which we only know fragments. Antiquity was not just a time of temples, military campaigns, and speakers. It was also a time of technical creativity. People knew how to use levers, pulleys, and cranes. One experimented with automatons, hydropower, and pneumatics. Heron of Alexandria described devices centuries later that seem like toys, but reveal mechanical thinking at a high level. The Antikythera mechanism fits into this tradition, yet it stands out far beyond it. It is the point where technology almost becomes modern precision engineering. Why this knowledge was not continuously passed down is another bitter question. History is not a linear ascent. Progress is not an escalator that one simply steps onto. Empires crumble, libraries burn, trade routes break down, workshops disappear, masters die without passing on their art, and sometimes knowledge simply gets lost, just like the ship off Antikythera. Perhaps therein lies one of the greatest lessons of this discovery. Civilization is vulnerable. Knowledge is not automatically secure. What one generation builds, the next can lose. And what is once lost does not have to be easily found again. The Antikythera mechanism reminds us of this with the force of a silent proof. At the same time, it also tells an encouraging story. For although this machine lay on the seabed for almost 2 millennia, although wood rotted, bronze corroded, and parts were irretrievably destroyed, it has survived. Not completely, not intact, but enough to convey its message. Enough to show us that the people of antiquity were capable of achievements that we have long underestimated. This is more than just an archaeological sensation. It is a correction of our arrogance. Modern man likes to consider himself superior, digital, connected, scientific. And certainly, our technology is incomparably more advanced. But the Antikythera mechanism forces us to clearly distinguish between more performance and more intellect. The ancient Greeks had no microchips, no electricity, and no computer screens. But they had observational skills, mathematics, patience, and the ability to translate abstract connections into a functioning mechanical system that deserves not just admiration, it demands respect. One can easily imagine how a scholar of antiquity might have used this device. Perhaps it stands in a library or a private study. Light falls obliquely through a window. Papyrus rolls lie on a table. Somewhere there is the smell of wood, oil, and sea air. The user places a hand on a crank and turns it. Slowly, the gears inside begin to move. Hands travel across scales. Data becomes visible. Perhaps he explains the upcoming lunar phase to a student. Perhaps he shows when to expect an eclipse. Perhaps he proves that the cosmos is not arbitrary, but calculable. For us, that would be technology. For him, it may have also been philosophy. It is precisely this connection between science and wonder that makes the object so unique. It is a device of reason, and at the same time almost something poetic. Metal that imitates the sky, gears that reflect the movement of the sun and moon, a machine that comes from human hands yet represents the order of the universe. That is powerful, very powerful. Of course, much remains speculation. Some parts of the mechanism are missing. Some reconstructions are plausible but not definitively proven. There are scientific debates about the details of the displays, about the exact number of gears, about additional functions, and the original form of the device. Yet it is precisely these open questions that give it an additional tension. The Antikythera mechanism is not just a solved sensation, but also an ongoing research adventure. It is both a find and a thought experiment at the same time. And perhaps in the end, that is the most beautiful thing about this story. That it not only provides us with answers, but also sparks curiosity. It shows how much still lies in the dark, in the sea, in archives, in the gaps of transmission, and sometimes even in our own prejudices. For we tend to underestimate past cultures when their technology does not look like ours. We often confuse modernity with intelligence. The Antikythera mechanism cuts through this comfortable illusion with the elegance of a bronze gear system. It reminds us that history is deeper than school books often suggest, that the past does not consist of primitive stages of our present but of its own, highly complex worlds with their own achievements, and that occasionally a single artifact is enough to shake entire certainties. The ship off Antikythera sank at some point in stormy seas. People may have died. The cargo was lost. What was a catastrophe for those involved at the time became a time capsule for posterity. Between statues and goods rested a machine that apparently no one could save, and perhaps that was our fortune. For on land it might have been melted down, looted, or destroyed. In the sea, however, it was preserved, damaged but not erased. Thus, it could come to light again thousands of years later. And today, it symbolically represents something that extends far beyond antiquity. The persistence of human curiosity, the power of thought, the quiet miracle that even after centuries, we are still able to connect with past spirits, not through voices, but through constructions, calculations, traces of tools, and the movement of a pointer across a scale. When one looks at the Antikythera mechanism, one is not merely gazing at an ancient object. One looks at an encounter between past and present, between craftsmanship and science, between what was lost and what still remains. And perhaps one also looks at a reminder that true greatness often lies where one does not expect it, not in the loud, not in the shiny, but in the quiet precision of an idea that endures for millennia. The Antikythera mechanism is therefore much more than a find from a wreck. It is a monument to human ingenuity, a proof that the history of technology does not unfold as simply as we would like, and a hint that the past is still capable of surprising us, thoroughly, sustainably, and with full force. Perhaps therein lies its greatest fascination, not only that this machine existed, but that it still shames, excites, and compels us to think today. It comes from a distant world, and yet it feels strangely close, for its essence is timeless, the attempt to recognize order in the universe and to shape that knowledge into a form that can be understood, shared, and utilized. A person over 2,000 years ago may have grappled with the same idea that drives us today, to understand how the world works, and that is precisely why the Antikythera Mechanism is not merely a relic of the past. It is a message.